welcome to the computer class. Today we are going to start with a new chapter, chapter 2, encodings. The objectives of my today's topic are: you will learn representation of numbers, signed and unsigned representation of binary numbers, shortcomings of sign magnitude representation of numbers. Students, please open your book at page number 63. Representation of numbers. Numbers can be represented in many forms. They may vary in their base, such as binary, octal, decimal, hexadecimal, or in the position of the decimal point, such as 12.34, 1.23, and so on. As we had already learned number representations in our previous chapter, today we will start with the position of the digits of a number. In a number, the position of lowest significance is on the rightmost hand, which is called least significant bit, LSB. The position of highest significance is on leftmost hand and is called the most significant bit. For example, 215. Here, 5 is the least significant bit and 2 is the most significant bit. Now, open your book at page number 64. Signed and unsigned representation of binary numbers. Binary numbers are represented by using n-bit notation, where n indicates the bit length. Now, in case of 3-bit representation, the bit length is 3. If I say 4-bit representation, the bit length is 4, means the value of n is 4. Now, in case of unsigned numbers, there is no provision of negative numbers. Hence, there is no sign. In a n-bit representation, there can be values ranging between 0 and 2 raised to power n minus 1, where n represents the bit length. Now, let us consider an example. In a 3-bit representation, you have already done. When we did 2 raised to power 3, then value is 8. It means the value lies from 0 to 7. So, the smallest possible value is 0, 0, 0. And the largest possible value is 1, 1, 1. Because binary equivalent of 7 is 2 raised to power 3 minus 1. 2 raised to power 3 is 8 and 8 minus 1 is 7. Now, signed representation of binary numbers. Signed representation of binary numbers represent positive numbers, then negative numbers and 0. There are 3 ways of signed bit representation. Number 1, sign magnitude representation. Number 2, ones complement representation. Number 3, twos complement representation. Now, we are going to start with sign magnitude representation of a binary number. In this form, the MSB means the bit on the leftmost hand. It represents the sign of the number. Means 0 represents a positive number and 1 represents a negative number. So, for a n-bit representation, 1 bit is reserved for the sign of a number, and the remaining bit are used for storing the number. Now, let's consider an example. The 4-bit representation 100 will be -4. Why? Because first bit is for sign and rest of the bits are used for storing number. So 100 is 4 and here this MSB is 1 and 1 is reserved for negative number. So in a 4-bit representation, -4 will be represented as 1100. Now let's consider another example. Here we take 0011. Now these 3 bits represent 3. Yes. And this 0 is an MSB which represents the positive number. So here 0011 is the value for +3. Now our next topic is shortcomings of sign magnitude representation of numbers. Students, please open your book at page number 65. There are 2 representations of 0. As we know, 0 has no magnitude. But when we talk about sign magnitude representation with n bits, then there will be 2 representations of 0. One with the sign bit 0, that will represent it as negative, and the other with sign bit 1, that will represent it as positive. So in a 8-bit representation, 0 will be 0, 0, 0, 0, 0, 0, 0, 0. And in a 8-bit representation, -0 will be 1, which represents the sign magnitude representation 0, 0, 0, 0, 0, 0, 0. This was the first shortcoming of sign magnitude representation of numbers. Second shortcoming is that the sign of the numbers need to be examined and processed separately before doing any calculation. Yes, before operating on them for addition or subtraction, the sign bit of the numbers needs to be processed. Now, second way to represent the sign binary number is ones complement representation. In this form, positive numbers are their normal binary equivalent, as we had done in our previous chapter, while negative numbers are the ones complement of the normal binary representation of the magnitude. Now let's consider an example. First example, represent +9 using ones complement representation using 6 bits. Now students, what is the binary equivalent of 9? Yes, it is 1001. And it has how many bits? 4 bits. Now, as we have to represent the number using 6 bits, so we will add 2 leading zeros before the number. So this number becomes 001001 and it represents +9 in 6 bits. Second example. Represent -9 using ones complement representation using 6 bits. Now, you know binary equivalent of +9 is 001001. So, when we are going to calculate -9 with the ones complement, what we will do? Ones complement means to invert 0 to 1 and 1 to 0. So my answer is 10110. Now, open your book at page number 66. Note, negative numbers will have a 1 in the MSB and positive numbers will have 0. Double representation of 0 as in previous case. Plus 0 in 6 bits will be 0, 0, 0, 0, 0, 0. And minus 0 in 6 bits will be 1, 1, 1, 1, 1, 1. Now our next topic is 2's complement representation of a binary number. In this form, positive numbers are their normal binary equivalent. Means you are not going to perform any of the operation on the positive numbers in 2's complement representation. While the negative numbers are the 2's complement of the normal binary representation of the magnitude. Let us consider an example. Represent plus 14 using 2's complement representation using 6 bits. The binary equivalent of 14 is 1110. Students, this is wrong. Please cut it on your book. Yes, the binary equivalent of plus 14 is 1110. So in 6 bits, plus 14 will be represented as 0011110. Let us consider another example. Represent minus 14 using 2's complement representation using 6 bits. The binary equivalent of 14 is 0011110. So for a negative number, we are going to calculate its 2's complement. And the answer is 110010. Note, negative numbers will have a 1 in the MSB and positive numbers will have 0. Number 2, 2's complement gives the same representation of plus 0 and minus 0, since 2's complement of 0 is 0 itself. Students, today you have learned representation of numbers, signed and unsigned representation of binary numbers, shortcomings of sign magnitude representation of numbers. Do practice the related examples. Thank you.